Hello everybody, welcome to the video for topic number 9, equations of lines. In this video we're going to show you how to use both slope-intercept and point-slope form to write equations of a line. And we're also going to write equations of vertical and horizontal lines and also write equations of parallel and perpendicular lines. So we've taken you through and we've shown you how to graph equations, but now we're going to show you how to write the equations given different properties. Again, one of the things we want to do is we want to make sure all of our equations end up in this y equals mx plus b form, where again m is the slope and b is the y-intercept. We have to identify those two things as we go through and write equations. Now, x and y are just coordinates that can fit in it and work. So a lot of the times we're going to be given coordinates and we can plug those in for x and y to help us be able to solve it. If we're given a graph, there's a couple different ways that we could do it. Again, we want our answer to be equals y equals mx plus b. And we can look and see on this graph that we know the y-intercept. The y-intercept in this case is -2. So I know that -2 is going to go in for b. For the slope, we can use rise over run. So we know we go up 2 and to the right 3. So our slope has to be 2/3 x. So the equation of this line would be y equals 2/3 x minus 2. Again, also remember we can use our slope formula to find that slope as well. The slope formula is y2 minus y1 over x2 minus x1. So if you don't want to use rise over run, don't forget we have a formula for slope to be able to calculate it algebraically. Use the slope-intercept form of a linear equation to write the equation of a line with the given slope and y-intercept. So again, we want everything to end up y equals mx plus b, and we're going to plug in for m and b. Well, here they give us the values. So for example, for a slope of -1 and a y-intercept of 0, 4, our equation is y equals -1x plus 4, or we could just say y equals -x plus 4. Remember, if there's a 1 for the slope, we really don't need to write it unless if we want to. For b, it's the same thing. Y equals 1/3 of x, because the slope is 1/3. My y-intercept is 0, -7, so we'll say it is -7. Now for the last one, we have a slope, but realize our y-intercept is just the origin. It's the one that starts in the middle. So technically, we don't need to write this. So while you might write y equals -5 over 2x plus 0, more than not, we're going to commonly write it as y equals -5 over 2x, and just not write the 0 at the end. Not always are they going to give us the slope and the y-intercept, so sometimes we might have to go in and find it. And in order to do that, we're going to use this idea of the point-slope form. Now, the point-slope form is just another equation where we can go through and turn it into slope-intercept form. So our goal is to take it from from point-slope form and eventually turn it into slope-intercept form. The equation for point-slope is y minus y1 equals mx minus x1. And we're going to fill in the m, the x1, and the y1 spots. The m is just going to be some sort of slope, and the x1 and the y1 is going to be a coordinate that they give us that is not a y-intercept. So again, big thing here is we want to use x1 and y1 when we're not given a y-intercept. We're just given some other point that is in the line. Case in point here, if you look at all these examples, they give us a slope, and then they give us a point in the line. So our job is to be able to use point-slope form, y minus y1 equals m, x minus x1, and plug these things in, and then get our answer to look like y equals mx plus b. So as we go through this, we're going to start with our point slope, y minus y1 equals m. x minus x1. The slope is 3, so we're going to plug that in for m. And this is our point here, so we're going to call this point x1 and y1, similar to the way we did it when we found the slope using the slope formula. So y minus y1, so it's y minus 2, equals the slope 3, x minus x1, x minus 6. We're never going to touch these y and x. These y and x are going to end up being the y and x and y equals mx plus b. And our job now is to basically solve this for y. So in order to do that, we're going to distribute the 3 here. Y minus 2, 3 times x is 3x. 3 times negative 6 is negative 18. And now I have to get y by itself. So I will add 2 to the other side. Y equals 3x minus 16. And now this is in slope-intercept form. So this would be the equation of my line. Y equals 3x minus 16. We could check this because if I plug 6 back in for x, 3 times 6 is 18. And 18 minus 6 gives me a y of 2, which gives me back the point that I have here. Let's do the same for the second problem. Again, we're going to take y minus y1 equals m x minus x1, and we're going to plug in the points. They give us the slope, they give us x1, and they give us y1. Y minus y1 is y minus negative 5. Now again, remember, it's y minus negative 5. That negative on the 5 is not the subtraction that's up here. Those are two different values. The slope is negative 2 over 3. And then we have x minus 1. So one of the things we're going to do first here before we do any further is we're going to simplify this double negative. This double negative here will turn it positive. Everything else will stay the same. Let's go ahead and distribute this in here. I have y plus 5 equals negative 2/3 times x is negative 2/3 x. Negative 2/3 times negative 1, well, negative times negative becomes positive, and 2/3 times 1 just stays as 2/3. Anything times 1 stays the same. I want to get y by itself, so I need to subtract 5 for both sides. Y equals negative 2/3 x. Now for here, I need to be able to do 2/3 minus 5. So remember, when I subtract fractions, I need a common denominator. So I'll change 5 to 5 over 1. This will make it 2/3 minus 15/3. 15 over 3 becomes 5. 2 minus 15 gives me negative 13 over 3. So here is my equation written in slope-intercept form. We'll do it one more time with this problem over here. Again, the same idea. We want to plug it into point slope and be able to turn it into slope-intercept form. The slope is 3 over 2. Here's x1, and here's y1. Again, these are both negatives, so don't plug those negative ins for those subtractions. So we're going to have y minus negative 7 equals 3 over 2 x minus negative 2. And both of these double negative here are going to become positive. Y plus 7 equals 3 over 2 x plus 2. I'll distribute 3 over 2 into both parts. Y plus 7, 3 over 2 times x is 3 over 2. 3 over 2 times 2. Well, 3 times 2 is 6. 6 divided by 2 gives me 3. So 3 over 2 times 2 just gives me 3. My job is to get y by itself, so I will subtract 7. Y equals 3 over 2x minus 4. And again, when it's solved for y, it's written in slope-intercept form. The equation that works is y equals 3 over 2x minus 4. So again, we're going to use this point slope form idea to be able to solve it. We're plugging in for m, x1, and y1, and then we're solving it through to be able to find the equation. Again, let's do the same thing, but now they don't give us the slope. They just give us 2 points. So a couple things we'll remember. We again want to be able to use point slope to be able to go through and turn it into slope-intercept form. Y equals mx plus b. But this time, they don't tell us the slope. So we have to remember our formula for slope. As long as we have 2 points, we could take the difference in the y's and the differences in the x and plug them in. So let's go through and try this. So first, we're going to find the slope. I'm going to call this x1, y1, x2, and y2. We got to get the slope first. So the slope of this would be 4 minus 0 over 5 minus 3. 4 minus 0 is 4. 5 minus 3 is 2. 4 divided by 2 is 2. So now I know the slope, and I know at least one coordinate. Now, again, you can use either coordinate when you do this. It does not matter. If you want to use the one that you called x1 and y1, that's fine. If you want to change the x2, y2 to x1 and y1, that is fine. As long as you use the slope, either one of these coordinates will work. So for me, I'm going to use this coordinate since I already called it x1 and y1. So I've got y minus 0 equals 2x minus 3. I'll distribute the 2 into here. 2 times x is 2x. 2 times negative 3 is negative 6. And y minus 0 doesn't really do anything, so I could just kind of get rid of the 0. And I'm left with my answer. Y is equal to 2x minus 6. And again, I should be able to plug both of these points in here and it come out to be true. So for example, 3, 0, if I plug in 3 for x, 3 times 2 is 6. 6 minus 6 gives me back to 0. And then for this one, 5 times 2 is 10. 10 minus 6 gives me back 4. So I know that is a good solution. Let's do the same over here. Let's call this x1, y1, x2, y2. I don't have the slope, so I have to find it. I'm going to do 5 minus negative 4 over 5 minus 8. The double negative at the top is going to become a positive. 5 plus 4 is 9. 5 minus 8 is negative 3. 9 divided by negative 3 tells me my slope is negative 3. Now for this one, I'm actually going to show you. I'm going to use this one. Even though I called this x2 and x1, y2, I'm going to use this point when I do point slope. I'm just going to rename it x1 and y1 when I plug it in. So it's y minus 5 equals negative 3x minus 5. Again, I'll distribute the negative 3 to both sides. Y minus 5 is negative 3x plus 15. I'll add 5 to get y by itself. Y is equal to negative 3x plus 20. This would be the equation written in slope-intercept form. So again, it's the same idea we did before. This time they didn't give us the slope. And if they don't give us the slope, make sure we use this slope formula here to be able to go through and solve it. Write the equation of these lines. Now, they only give us 1 point, but they give us a hint that these lines are vertical and horizontal. And so for this, we're going to kind of go back and use our knowledge of previous notes. So let's take a look at this. I have a line that goes through the point 2, 4, and they tell me the line is a vertical line. So if we remember back when we did notes earlier, we know that vertical lines only exist when they go through the x-axis. So this is an equation that only has x. Well, the x value that it goes through is 2. So the equation of this is x equals 2. So if they tell you it's vertical, it's just the x, and it goes through the x value. You could probably guess what's going to happen for the one that's horizontal. We remember the one that's horizontal goes through the y-axis. So negative 1, negative 3 is this point. and I graph a line through it. And I know that horizontal only goes through the y-axis. So it's going to be y equals whatever y is. And in this case, that's y equals -3. So remember, vertical and horizontal will not end up in that slope-intercept form. Vertical lines will have just x, and horizontal lines will have just y. This is the same thing, except this time they're trying to tell us the slope instead of telling us it's vertical and horizontal. We just have to remember, what does each slope mean? So in this case, we remember that the only way you can have an undefined slope is with a vertical line. So we have a vertical line that goes through 0, 3. So 0 is nothing left or right. 3 is up or down. So we have a vertical line that actually goes through the y-axis. So this would be my vertical line. Vertical lines are x, so x equals whatever the value for x is. So in this case, the equation is x equals 0. And we remember, if our slope is 0, we have a horizontal line. Again, a horizontal line goes through the y-axis. 1, 2, 3, 4, 5, 6 to the left, and 4 up. So our graph goes through and looks like this. And if it's a horizontal line, it has to be y equals. So in this case, the y value is 4. So y equals 4. So again, if it's undefined, that's just another way of saying it's a vertical line. And if it's a vertical line, it only goes through the x value. If the slope is 0, that's just another way of saying it's a horizontal line. And for a horizontal line, it goes through the y values. Horizontal and vertical lines are the only way that it doesn't end up in slope-intercept form with our y equals mx plus b. Vertical and undefined will end up as x by itself, and horizontal and slope of 0 will end up as y by itself. Now we're going to find equations of parallel and perpendicular lines. So we have to remember about their slopes from previous lessons. We remember that if two lines are parallel, they're going to have the exact same slopes. And if two lines are perpendicular, they're going to have opposite reciprocal slopes. And again, we remember we talked about, if it's an opposite reciprocal, you take the opposite sign and you flip the fraction. So 4/5 would become -5/4, or for example, 6/5. Let's call that -6/5 would become +5/6. So we're going to use that advantage to our knowledge to be able to write equations. Here they want us to write an equation that goes through the point 0,3 and is parallel to 2x minus 1. So again, as long as we know one point and the slope, we can use point slope. Now, we have the coordinate, and we also have the slope, because we remember that if our slope is parallel to this, then it has to be the same. So the slope of this line is 2. So that means our slope also has to be 2 if it's parallel. So now we know the point, and we know the coordinate. We'll call this coordinate x1 and y1. We'll go through and plug it in. Y minus 3 is equal to 2x minus 0. Distribute the 2 here. Y minus 3, 2x minus 0. And then we will add 3 to both sides. Y equals 2x plus 3. So again, we're getting the knowledge of our slope based off the fact that we know that they're parallel. And if they're parallel, then we know their slopes are the same. Same thing for B. Here's our coordinate, x1 and y1. Because it's parallel, we know the slope is going to be the same of whatever the slope is here. Now this time, we're going to have to solve this for y to be able to figure out its slope. So let's do that. I'm going to move the 2x to the other side, start to get y by itself. Negative 3y equals negative 2x plus 1. Divide everything by negative 3. I get y is equal to negative 2 over negative 3 becomes positive 2 over 3x. 1 divided by negative 3 is negative 1/3. So here's the slope of the line that we're parallel to. It's 2/3, which means our slope also has to be 2/3. And now we have enough information to go through and plug in the point slope. So y minus y1, so y minus 4 is equal to 2/3 x minus 1. We'll distribute the 2/3. Y minus 4 is equal to 2/3 x. 2/3 times negative 1 is negative 2/3. I'm going to get rid of the negative 4 by adding it. I know that in order to add fractions, I need common denominators. So negative 2/3 plus 4, which we'll call 4 over 1, is the same thing as doing negative 2/3 plus, if I make this denominator a 3, I need to make this a 12, because 12 divided by 3 gives me 4. Adding these together, that gives me 10/3. So y is equal to 2/3 x plus 10 over 3. So again, they didn't give us the slope, but they told us it's parallel. So if two lines are parallel, we know their slopes are exactly the same. Now they give us a point, but instead they tell us the slope is perpendicular to this line. So again, we have to remember perpendicular means that they're opposite reciprocals. So if their slope is negative 4 and we're perpendicular to this, I need the opposite reciprocal of negative 4. So negative 4 over 1, negative becomes positive, and we flip the fraction. Here is our slope. Our slope we're going to use is 1/4, because 1/4 is an opposite reciprocal to negative 4. Here's x1 and y1. We now have enough information to plug it into point slope. We'll go y minus y1, so y minus negative 2 is equal to 1/4 x minus 0. Distribute the negative 1, we're going to distribute the positive 1/4. We'll also change this double negative to a positive at the same time. Y plus 2, 1/4 times x is 1/4 of x. 1/4 times 0 is just 0. We'll subtract 2 from both sides. Y is equal to 1/4 x minus 2. So again, very similar to what we just did, but again, perpendicular means that we need to take the opposite reciprocal of whatever slope for the line they're given to us. Parallel, we could take the same, but perpendicular, we will take opposite reciprocals. Let's try it again on this last problem. Again, we're through the point negative 6, 4. So here's x1 and y1. Our goal is to be able to put it into point slope. We just need to be able to find a slope that's perpendicular to this. So we need something that is an opposite reciprocal to this. We're just going to solve this for y to be able to find the slope. It's minus the 2x from each side. 5y is equal to negative 2x plus 10. Divide everything by 5. I get y is equal to negative 2/5 x plus 2. So here's their slope. It's negative 2/5. We need the opposite reciprocal of that. Well, the opposite of being negative is positive, and 2 over 5 becomes 5 over 2. So we're going to use this slope of 5 over 2 going through the point negative 6, 4. So y minus 4 equals 5 over 2 x minus negative 6. And again, I'll take this double negative here, and I'm going to turn it into a positive value. We'll distribute the 5 over 2 into both of these. 5 over 2 times x is 5 over 2x. 5 over 2 times 6. So 5 times 6 gives me 30. 30 divided by 2 gives me 15. So this turns out to be 15. I got to get y by itself, so I will add 4 to the other side. Y is equal to 5 over 2x plus 19. So again, all of these have been the same way, just different ways that we found the slope. Sometimes they've given us the slope. Sometimes they gave us 2 points, so we could find the slope using the slope formula. Sometimes they told us that the slope is parallel to something. Well, we know parallel lines have the same slope. And the ones we did at the end, the slopes are perpendicular. So if we were able to find the slope of this line, which again was -2/5, we realized its opposite reciprocal was 5 over 2, and that's what we used for our slope. So again, a lot of different ways just to find the slope, and then we plug in the point into point slope to be able to write our equation.